Testing, testing. Hi, thank you everyone. My name is Alan. I'm the Senior Partner Manager for Wikidata. I come from Wikimedia Deutschland, which is Wikimedia Germany. Thank you for having me today to give a talk about Wikidata, Wikimedia's knowledge graph in a world of generative AI. Wikidata is one of the largest Wikimedia projects, right? I think the most common Wikimedia projects that everyone will know is Wikipedia. And apart from that, the largest one is Wikidata. So the data in Wikidata is used in a lot of technology that you use every day. And all data in Wikidata is available in CC0, which means that anyone and everyone in the world is free to use and reuse Wikidata's data for whatever projects that you fancy or you wish to do, and you do not have to tell us or tell anyone. The data on Wikidata is made for humans and machines, so not only humans are able to interact with the data on Wikidata, but more importantly, machines are also able to interact with Wikidata. One of the unique things about Wikimedia projects and Wikidata, it is multilingual. We support, I think, close to 300 languages or so. And increasingly, the different communities all over the world who are working on Wikidata and Wikimedia projects, they are also trying to increase the amount of languages that they can support on Wikimedia projects. So Wikidata is collaborative, which means to say that anyone and everyone in the world is able to make edits on a similar item that you have in different languages that you so preferred. And more importantly, it is a free and open knowledge graph. So the reason why I'm talking about this is because Wikidata was created by Wikimedia Germany and continues to be maintained by us. So, yeah. Wikidata is not only a standalone project, but at the back of it, it also supports most, if not hopefully, eventually all of Wikimedia projects, including Wikipedia, the structured data for Wikipedia, and also Wikimedia Commons as well. So if you would like to have your own little mini Wikidata in your projects or having your own knowledge graph, you can use our free and open software called Wikibase. Wikibase is the software that is powering Wikidata, and it enables you to have your own Wikidata self-hosted, or it can also be hosted by us, called the Wikibase Cloud. The self-hosted Wikibase software is called Wikibase Suite. If I'm speaking too fast, please feel free to let me know. I try to slow down a bit, yeah? Interestingly, I want to share with you, so if you have your own Wikidata, you're able to connect, or Wikibase, you're able to connect your Wikibase with other knowledge graphs, which are also using Wikibase, and also with Wikidata as well. So this is our vision that we have the link open data web, so all the knowledge can be shared across to all the different instances all over the world globally. So knowledge becomes free and accessible. Yeah? Okay. So why are we talking about Wikidata and AI? So I just want to come into this interesting project that we are working on over the past 1.5 years to share with everyone in the world. And of course, it is my honor to share with the community in Taiwan as well. The AI, the view at the big picture, I'm sure most of you know, is that the hype of AI has just came up because of ChatGPT, but it is only one part of the generative AI. Artificial intelligence has been around for a fairly long time. Machine learning has also been around for a fairly long time, but most of the lay people, like my mother, my grandparents, they do not hear about this before, and only recently it's because of the hype of large language models and generative AI, and then we increasingly see the trend to AI coming up as a result of this. However, I just want to share that AI has been around for a fairly long time, and machine learning as well. And artificial intelligence as a whole has got different areas of artificial intelligence. They can use AI in planning, in robotics, in image recognition, speech recognition has been around for some time. But like I said, more recently, the natural language processing, the text generation, question answering, machine translation is increasingly become more and more trendy. Let's put it this way. So, having said that, Wikidata has been used by several AI projects for a fairly long time. I just want to share some of the use cases with you, or some of the examples with you, so that you have an understanding of Wikidata and who is reusing Wikidata's data, and Wikidata's role in AI today, right, and in the future as well. So in this example, we have the TextVec. This project, Wikidata, provides important entities, stable identifiers, for the information and important information about the entities about them, right? So this is an example of name entity recognition. I'll be sharing this. In fact, I've shared this document, this presentation on Wikimedia Commons, and also share it with COSCUP. So if you want to go back to my deck, you can feel free to look at it later. So no need to stress about trying to take notes or something. Yeah. So Wikidata is also being used as a name entity disambiguation. We provide important entities and information about them, and OpenAI, for example, is using Wikidata. Like, for example, the man saw a jaguar speed on the highway. The jaguar, does it refer to the car? The jaguar refers to the animal, or what does the jaguar refers to? So at the back end of it, Wikidata provides name entity disambiguation. So classification, Wikidata provides relationships and hierarchies through its ontology, right? Quora, for example, has used Wikidata. And of course, in question answering, Wikidata acts as background knowledge to answer natural language questions by the big tech companies all over the world, and also many of the AI companies that's been using Wikidata data. So LLM-powered system versus or vis-a-vis knowledge graph-powered systems. As you know, Wikidata is a knowledge graph. We are not a large language model. So just a quick overview, for large language models, they learn to predict the next word. Large text corpora that are not machine understandable, it requires significant amount of training data. And a lot of this training data is actually quite questionable, because you, as a user, you do not know where they source the data from and how the data is being trained. And most of these are not transparent or validated in their inference or training. It's hard to inspect and therefore hard to predict or debug. Whereas for knowledge graphs, like Wikidata, for example, it is explicitly modeled. The data and relationships are machine understandable. You only need to explicitly model relationship once. For example, in Wikidata, we have this entity schema. And it's also easy to inspect and debug the entities on knowledge graphs. And it can be used to validate text, such as the LLM output, and links the graph to provide knowledge. And of course, in Wikidata, as a knowledge graph, there are citations that are provided within the knowledge graph, so there's validation involved, right? However, what we are seeing from a Wikimedia Germany perspective is that firstly, the large language model hype continues. The advanced artificial intelligence is just ever more improving. Every week, every month, every half a year, every year, the technology improves more and more. Large language models are thought to progress in that direction, and the trend is going to be going upwards. Yeah. This is highly influenced by financial interests. You have a lot of venture capitalists, angel investors. They put money into AI models, companies that are developing different AI technologies and as a result of this, the industry is the one that is pushing the development of this technology. More and more graduates or students, before they graduate, are taking courses on artificial intelligence because they they want to be part of the hype as well, right? However, for large language model developers, knowledge is not the goal for them, right? This is something that we understand by now, right? They're not really concerned about knowledge per se, but they're concerned about how much content they can put in and how they can train their model as efficiently as possible. At the same time, the skepticism is growing. In some aspects, the idea that we are hitting a wall of LLM is gaining traction. And we recognize that we need to look at each other, right? New and old techniques, not only just the newer techniques, but also looking back at what other techniques that we have been using, for example, the knowledge graph, to see how we can supplement that together. And to a certain extent, we increasingly see different companies, different projects coming together to combine different techniques and systems, right? Pure large language models are no longer considered sufficient due to some of the criticisms that people have with regards to what they are doing. The third thing that we have observed in this trend is that, generally people are too easily convinced by large language models, especially conversational interfaces, that kind of build unwarranted trust. And we are seeing the ELIZA effect in action and scale. ELIZA effect is, as most of you may know, is the personification of a AI technology, and the society at this point in time is adapting, right? I think the audience here, we're quite privileged. We come from a background where we understand, the technology, but when we look at how the general public is using AI and the trend and hype they have been pushing for AI, this is something that, covers more of this, right? Because to them, it's just a tool and it's a shortcut that they can use, for many of the tasks that they're doing. Social backlash is forming, especially in Europe and North America. Some people are starting to realize what the worst outcome of AI will mean for them and are starting to organize into different communities and groups together, right? And many people are starting to realize that the real world potential utility of AI and not AI, and most of such functions are derived for financial gain. So what happened to knowledge graphs like Wikidata now, in the trend of Gen AI? So we provide a base of knowledge. Okay, knowledge graphs are a great source of explicitly modeled knowledge about the world and can be used to improve AI results, especially we combine with different AI techniques. We give people agency in what is happening, right? Open knowledge graphs like Wikidata is a way for people, everyone, you and me, right? Everyone in the world, to have an influence on the technology that are built on them, right? Unlike large language models, where you do not know where they get their sources from to train their models. Knowledge graphs validate and inform. So the knowledge contained in the structure of knowledge graphs, especially, those provides context by which the AIs can understand more in their training data. And the results of these large language models can be processed for authenticity by comparing to knowledge graph information. So knowledge graphs is not redundant, it's not the past, it is actually has a role that is providing in the world of Gen AI. And we provide greater context, right? Because open knowledge graph, like Wikidata, we provide citations, conditions, qualifications, and then we can inject more context into AI systems. The citations and qualifiers of Wikidata can provide updated, validated information, and this same information can improve the validation and content, right? So, in terms of correctness, knowledge graph provides explicit, accurate, and reliable human-generated content by you and me, by everyone in the world, right, by the Wikidata community. Whereas Gen AI generates responses based on statistical patterns and may hallucinate. For example, in this example, if you ask Meta Llama, right, who took the 4th place in the world in the women's single event at 1988 Winter Olympics figure skating competition, and then Llama gives you a response. But if you go to Wikidata, you will realize that the 4th place is actually another person, right? Completeness, knowledge graph retrieves complete lists by querying structured databases, and Gen AI, limited by its recall capabilities, are often unable to provide comprehensive lists, right? If you make a query search of Wikidata, you get to see, many results, right? Like 6,307 results. Whereas if you ask Gen AI, they are only given one response from one query that you ask for, and you're unable to have an understanding of, okay, what are the possible results that you can derive from a query that you make. Freshness, this is important. For knowledge graph, because it is like Wikidata, it is live, it is community effort. It is easy to update and to reflect the latest data. For Gen AI, it's limited to information available up to the last training date with a knowledge cutoff. For Llama, for example, okay, in this example, you see when did Mark Cavendish retire, right? In Wikidata, the result shows you that, okay, it retires on 10th of November 2024, but the Llama example here, it provides that it does not officially retire because the cutoff year was 2022, and they're not able to have more current results as a result of that. Transparency, knowledge graph allows users to trace and verify the source of information, whereas Gen AI functions as a black box, right? With unclear and non-transparent processes, you're unable to inspect and or debug, what happens here. You ask a question to Gen AI, you get an answer, but what happens here, where did they get the sources from to give you the response and the answer? So, it's very hard for you to know, right? However, knowledge graph, we are not inherently generative, but we can derive new knowledge through ontology. Whereas Gen AI, they are designed to create customized, individualized content and adapting the responses to your user needs. In this example, if you ask them, hello, Llama will say, oh, hello, nice to meet you. Is there something I can help you with, or would you like to chat? So it's very friendly, it's very interactive, and it makes you feel like you want to engage more, and it makes you feel like you can trust this system more, right? That's a good thing about it, because it makes users more excited to use. Usability, knowledge graph can be complex to use, requiring the knowledge of Sparkle for information retrieval. For those of you who are not acquainted with Wikidata, one way to query Wikidata's data on Wikidata's data is through the Wikidata query service. You need Sparkle knowledge. Whereas for Gen AI is user-friendly, capable of responding to natural language queries. A teenager, in fact, a 10-year-old kid can, go to ChatGPT and ask a question in the most natural way, and then the kid can get a response easily. No one has to learn Sparkle, for example, right, to get a query from this. Interestingly, knowledge graph lacks the data needed to provide instruction, whereas Gen AI easily generates outputs to instructional queries. For example, this example that we see here, how to tie a slip knot, and then you have a response of the step 1, step 2, step 3, step 4, step 5, how to tie a slip knot from Llama. Whereas knowledge graph like Wikidata is not possible to do that. Yeah. So, having said that, what are we doing at Wikidata? We are trying to create a Wikidata vector database. A vector data, I'll just run through this quickly because I assume that most of you here are quite familiar with what a vector database is. But for those who are uninformed, this is a chance to learn more about it, and you can talk to me about it later. So vector database is a database that stores data as a vector representation, and it enables natural language search capabilities. So, for example, if you ask the question, who is Maya Angelou's spouse, then in this way, and not as a Sparkle query, you will query the vector database, and then the Wikidata vector database is here, right? This is Maya Angelou, and then you see all the connections, and then it will return you with the relevant results, which is this person here, or if you ask, the American poet activist is also Maya Angelou. So instead of learning Sparkle, you're able to query in this way when we have the vector database. So vector is a representation of data transformed into a set of numerical values, and these numbers are interpretable and meaningful to machines. Text, right? You input the text into LLM, AI, and generated a vector representation. For example, a king is actually, represented in this numerical value. Man is represented in this numerical value. So king minus man plus women equals queen, right? So instead of having the text of queen, man, woman, king, they're all represented numerically, and this is what a vector database looks like. So it allows for mathematical operations, facilitating analysis and comparisons of data. It also allows clustering, right? By grouping data based on their contextual meaning. For example, you have orange, right? Is orange a fruit or is orange a color, right? Yeah, so this allows us to do this kind of clustering, and you can see kiwis can also be a fruit, can also be an animal as well. So vectors can represent entire sentences and not just individual words. So for Wikidata, the vector database that we are creating right now, vectors can incorporate descriptions and claims of entities. Semantic search, right? Use of vector database representations or queries to match them with semantically similar Wikidata entities, right? Like which animals can be pet, for example, and then, it embeds the query into our, AI system and then map the vector into the vector space. So, in short, we have the Wikidata knowledge graph that we see now is all linked. Every item is linked to one another. And we're transforming these entities into vectors. And then we are creating a vector database, which then allows users to make a query in a natural language to the vector database, and then you have a return of an item, instead of having to learn Sparkle query language and to make a query on it. Yep, so I've talked about this, very quickly. Oh yes, just want to share this point here. We are working with two companies. One is called DataStax for the vector database, and Gina AI using the engine that they have. And right now we're working with the English language first, but we intend to support more than 100 languages as our project grows and develops. Okay? So, English, German, French, Chinese, Mandarin, and multiple languages as we grow this project. Okay, some of the use cases that a vector database can be used. Retrieval augmented generation, RAG, right? Integrating Gen AI with external databases to reference accurate, up-to-date data while generating output. This is a very interesting use case that we believe that many of the experts out there will be able to do this. By the way, I just want to share that the vector database is all open, right? Free and open. So if you are working on any AI projects, please feel free to use the vector database that we are building. Or if you want to try, also join in the project and then can give feedback and see how we can improve our projects. Yes, so for a vector database, you can query the database, right? For example, who is Maya Angelou's spouse? And then we will return you with a relevant entities with the relevant QIDs so that you will be able to see, go back into Wikidata, right? From Wikidata, and then from there you can see, okay, so the results is going to be items on Wikidata, and these are the items on Wikidata. So, of course, eventually we hope to, at this stage, to provide the data to Gen AI, and then the response will be this, and here are some references. The RAG use case is a good one because it helps to reduce hallucination. It retrieves reference information and to minimize errors because of Wikidata as the back end of it, right? Which is a knowledge graph, and then Wikidata's knowledge graph is being converted to vector databases, and this is constantly being updated, so information is always being updated. Reduces misinformation. It allows users to verify information and to trace sources for accountability. Ensures freshness. Gen AI references constantly updated information from Wikidata. It also amplifies underrepresented languages, knowledge as well. This is something that's very close to our Wikimedia movement overall. Contributions to Wikidata have a stronger impact on Gen AI and preserving diversity against dominant sources, right? Indigenous knowledge, indigenous culture, indigenous languages, for example, because they are contributed on Wikidata, and then we have a vector database. So if you query through the Wikidata vector database, then the knowledge becomes more complete, right? Instead of some other engines, that you may not know. Usually, you do not know. Thank you. What are the where the sources are from? Yeah, just a time check there. That's why I have to go through this fairly quickly. So the process of linking a name entity in text to its correct reference in Wikidata, for name entity disambiguation. The reason why this is interesting is because, for example, sorry, my bad, yeah. John Smith, there's so many John Smiths, in the history of the world, and also so many John Smiths in the Wikidata. So if you want to ask, okay, who created the man playing the flute, or then it will give you a result of the John Smith, right? And you'll be able to see the name entity disambiguation from this. Query the vector database, and then it comes out, give you a retrieve relevant entity, and they call you the result here with a QID, right? They always, if you know Wikidata, every item has a QID, yeah, unique QID, so it will give you a unique QID. Yeah, I think you can look into this later, so I just want to give some time for questions, because then it's more interactive and more fun. So name entity disambiguation, classification, the task of assigning predefined categories or labels to a given text based on its content. For example, a news article, it can give you the different classification of which category an article is about, through the database that we have, right, that we're trying to create. And this whole big project that we're talking about, the Wikidata vector database, is called the Wikidata Embedding Project. Thank you. 3 minutes. Our goals, at Wikimedia Germany, is to create an open source vector database on top of Wikidata. So instead of the existing knowledge graph that everyone knows and everyone loves, we want to create open source vector database for everyone in the world to, especially open source projects, to work with. We want to improve accessibility by enabling the semantic search on Wikidata, right? And also encourage open source AI and machine learning community to build AI projects with Wikidata. So we are investing a lot of resources to create this with these goals in mind. If you want to test a prototype, check out our Wikidata embedding project page. You have feedback, you want to talk to us, you can join a discussion project here. My colleague Philip, he's the one who is the technical person who's responsible for this project. You can write email to him if you have any queries or any feedback. My name is Alan, and I'm the senior partner manager. I'm the one who is facing institutions globally on Wikidata and Wikidata related projects. If you have any questions, feedback, collaboration, you want me to conduct workshops to train your community on Wikidata, please feel free to write to me. If you want me to give talks on Wikidata and updates on what we are doing, also get in touch with me as well. Very happy to support. Thank you for your attention.